The question is simple. Have any of the systems on my network been compromised? The answer is harder than it should be. Enter AI Hunter. Active Countermeasures has automated and streamlined techniques used by the best pen testers and threat hunters in the industry to create AI Hunter, a network threat hunting solution that does the first pass of a hunt for you to identify systems that are most likely to be compromised and scores the results on a scale from 0 to 100. You can then research those systems in depth with AI Hunter. Focus your valuable time on the systems that need your expertise with AI Hunter. Sign up for a personal demo today at securityweekly.com/ACM. Welcome back, everyone, to Enterprise Security Weekly. We are an official media partner for the virtual Black Hat 2020 event. To register and save $200 off, you can visit securityweekly.com/summercamp2020 and click the register button. Use the discount code 20SecWeekBH. Alongside Black Hat, of course, we are running our conference micro interview series. You guessed it, virtually, in an event called Security Weekly Virtual Hacker Summer Camp. It'll be August 3rd through the 6th. Options and pricing are available if you are a vendor and would like to do an interview with us and tell the world about your product and why it's better than everyone else's. Alongside the Security Weekly host, you can go to the same page, Summer Camp 2020. Is that right? Did I say that right? Summer Camp 2020? Okay, good. Let's see. Moolchandani is here with us. He's the Chief Technology Officer at Accurix, where he sets the technology strategy for the company. Prior to Accurix, was the Chief Security Officer at AutoGrid, leading cloud security for its energy and SaaS cloud. Was also the head of cybersecurity for General Electric's industrial cloud and edge platform Predix. Welcome to the show.
Thank you. Appreciate it.
And sorry, our listeners can learn more about Accurix at securityweekly.com/Accurix, ACCURICS. And today we are talking about immutable security. And I have to say, years ago when I first started messing with containers and such, the immutability throws you through a loop at first. And then, when we met, you were like, well, it's immutable security. I'm like, well, now we're taking it to the next level, right, with immutability. So I guess first start, tell us a little bit about the concept of immutable security.
So it has everything to do with the way today your cloud infrastructure is actually built. And it has more to do with the philosophy and the strategy rather than doing so much with the technical side of the things. Of course, there is technology that plays its role. So if you notice that cloud architectures now are built in multiple layers, the bottom layer is your cloud service provider layer, which allows you to build your essential cloud services. Like in case of AWS, it's EC2, S3, storage, and network. On top of it, you have your container orchestration layer, such as Kubernetes. And then on top of it, you have your own service mesh layer, HDO, Linkerd, console, whatever. All these different layers now have their own control planes to begin with, right? Now, these control planes today, one issue is that they have, because of these different control planes, you get in a situation where your governance kind of the cloud processes, especially in the cloud build and development phase, is fragmented. And that's where you start utilizing technologies like infrastructure as code to do automation for your cloud development and cloud provisioning. That's where the concept of immutability kicks in. So if you now are using infrastructure as code for building your cloud layers, it is expected that your change management also follow the same pipeline, the same process that you have used to build your cloud. But when you start deviating from that process, like you build the cloud using infrastructure as code, but then we are making changes directly into the cloud, that's where your immutability breaks. So immutability directly reflects how much you are able to maintain the single source of truth from the point of view of change management into your cloud. And when your immutability breaks, a lot of other things break as well, including security. And happy to dive into it.
Yeah, and it's interesting, my takeaway when you were describing this to me was you're scrutinizing the code that builds your infrastructure and your pipelines, such that we can put security like really early in the process. In other words, we can make it so that we can not build insecure infrastructure and make configuration mistakes, because now we're building it as code. We can scrutinize that code and the configurations associated with it, right, to identify those security flaws and automatically fix those, right? Like, don't build it that way. That's insecure. Build it this way, and recognize that before it's even built, which is a dream for us security folks, right?
Yeah. I mean, that's where the concept of born secure comes in. So we make sure, that your infrastructure as code is analyzed for all the security violations, posture-related security issues, including benchmarks. And should we discover them, then those have to be, remediated even before you are ready to apply that infrastructure as code to provision the cloud. So even if the cloud is born, you can make it secure. However, the ground reality is a little different. Organizations are still in the middle of their infrastructure as code journey. So there are environments out there which are 70, 80% still not being built using ISC. They're legacy environments. And that's where, interestingly, not only infrastructure as code has to be analyzed, but also your running cloud has to be analyzed for existing security issues.
John, I'll turn it over to you. You've got a lot of experience in this arena.
Yeah, and for our listeners, Am and I actually have known ourselves for a while. I first met him when he was back at GE, and I've always found him to be a super bright, intelligent guy, so I'm happy to be on here when he's on here.
Likewise.
And one of the things we had someone on ESW in the last few weeks, not from Accurix, another config play. And the thought I was asking them, and I think it'd be interesting for you to talk about Am as well, is when I first heard about what you guys are doing, it's like, well, why can't I just go use Terraform or pick my automation system and have it just go and rerun and resecure everything? But as you think more about what is actually necessary to do this type of space correctly, I think there's a lot more than just rerunning a tool to reconfigure things correctly. Would you agree with that?
Yeah, I mean, a lot of things have to be kind of brought into the consideration. For example, right, you have to be able to understand different types of relationships that are shared between the resources that you are about to build or the resources that exist in your cloud. As an example, right, in case of AWS, you have security groups where you identify whether they are wide open or not. You need to know that those security groups are actually applying to what EC2 instance is. So you need to know those relationships. Likewise, it may so happen that you identify that there's a security group which is open to internet, and it is applied to a EC2 instance, but that EC2 instance might be living in a private subnet. So you need to know the relationship that a EC2 shares with other subnets, whether it is public, private, there is an internet gateway attached to it or not, there is an ELB attached to it or not, and what are the ingress and egress rules. Only then you can actually identify that the violation that you are reporting actually has a threat context or an exposure context or not. And mind you, all these components now are codified. When they are built using ISC, you are building them using declarative language. So it's not just you have to do plain vanilla policy assessment using regular expressions, just check whether a certain parameter is enabled or disabled. You have to be able to build a full relationship graph between the resources on which you are reporting violations, and then combine those violations together with the help of these relationships, and also bring in a lot of other threat intelligence stuff here to be able to report effectively the violations which the customers have to go and actually remediate. A lot of times, these violations are not going to get remediated because there are so many of them. So these are some of the nuances which have to be taken care of when you are doing infrastructure as code security.
Yeah, it's interesting. It sounds like there's an attack simulation aspect of this, but applied to the infrastructure as code and deployment, right? Something smart is looking at all of those relationships, not just a policy, like you said.
Yeah, so we are trying to shift. Infrastructure as code security also involves shifting threat intelligence to left. So it's like now that you have the power of infrastructure as code, which also tells you what are the relationships, why can't we not apply the same principles that the adversaries apply when they want to do movements and when they want to do lateral movements, we identify those capabilities and possibilities right even before the cloud is built. So if we already know that you have a EC2 instance which is running an application, and that application has a server-side request forgery vulnerability, let's say, for example, and we know, looking into your infrastructure as code, that what is the IAM role attached to that EC2 instance. And if we know that that same IAM role is being used for provisioning S3 buckets as well, we exactly now know there is a possible path available for an attacker should this EC2 gets compromised because of a violation or a misconfiguration. The attacker straight away has the access to the S3 buckets because of this relationship, which is identity relationship. So we are able to identify these relationships ahead in the life cycle and apply threat intelligence to it to make a lot of meaning out of these violations and tell our customers that, look, you need to go and fix these ones first, because that's where your potential breach paths can exist. Now, doesn't mean that this is going to be the exact attack path that the attacker will take.
Right, but a popular one, especially for what is the financial company that had pretty much that exact same attack that you described. I don't know if it was Capital One or Bank of one of the large finance. I can't remember which one it was.
Capital One.
It was Capital One. Okay. Yeah, I mean, and that's important to know that one, to know that path exists, then know that it's in your infrastructure as code or in your infrastructure, and then what do you do about it and do the remediation? So how is the remediation part done once something is identified like that?
Right, and that's where products which are going to be doing infrastructure as code security are going to excel. Infrastructure as code security enables to do response as well now. So because your resources in cloud are built using infrastructure as code, and if that is what is your single source of truth, that is a place where you actually are going to do response as well after the detection. So consider this as a cloud detection and response. So you have EDR, consider this as CDR space. Because now we know the context, the semantic context of the code, and we know that this code was used for building. So for example, let's say you are using Terraform for spinning S3 buckets, right? We found that you have a S3 bucket in the cloud, which is violating certain configuration policy. We have the mapping for that S3 bucket, where it is actually being built, which Terraform file is being used to build that, right? That's where we go ahead and create the remediation code and provide that code to the developer. We use pull request-based mechanism. Mm-hmm. So we raise a pull request, assign that to the developer, and the developer now is able to remediate that violation using the same DevOps pipeline that the originally developer had used to build the cloud. So not introducing any new process into the DevOps workflow, but enabling the DevOps to follow the same process that they had used for building the cloud to remediate the cloud as well, right? That's the next generation of remediation. That's where the cloud remediation is moving.
And you're not necessarily rebuilding, but reconfiguring in a lot of circumstances, right?
Yeah, we're not rebuilding, we're reconfiguring, and we're also identifying the resources that were built but are now, say, unused. So we are able to identify those scenarios as well.
And Paul, this is sort of Accura's, what they're doing is a really great example of what I was hinting at during the news, right? Where I'm interested and excited now about security startups that they're not doing the same old thing. They're not handing you the 300-page scan report and say, Merry Christmas, go fix. So he's starting off with something that's newer and cleaner and easier to use. He's working with newer modern tools that are more developer friendly. You don't need to have as much dependence, I'm guessing, on the security team. And it's able to actually, in many cases, either correct or fix the issues. We're actually seeing tools now that are lowering that security burden on the developers and on the whole enterprise, not doing the reverse and, hey, here's another security tool, and now you need to go and work harder.
Right. And those are the solutions I'm excited about as a developer, right? The less security stuff that I have to worry about, the more I can focus on making my code perform better, more reliable, right? Meet all of the features, develop new features, not having to always have so much of a security burden, and know that I will get a pull request if I do make a mistake as well.
Yeah, absolutely.
That's really awesome. Can you model some of this out? As we've stated, there's different levels of maturity in pushing your applications to the cloud, right? I feel like those that are using infrastructure as code really, really heavily and really in the cloud are probably the minority still, or at least not all your applications are there. So is there like a modeling where I can build my scripts and deploy a test environment and kind of iterate through that before I go to production? Do you find that's some of the way that customers are using it?
Yeah, we are doing interesting things in that space. So, for example, as I explained that we are able to build different types of relationships, effectively 5 different types of relationships: native versus network, identity, access, privilege. These relationships are permitting us to actually build industry's first automated architecture diagrams or topology views for your cloud, your would-be cloud, right, by reading your infrastructure as code. We are able to simulate a lot of your cloud behavior right out of your infrastructure as code that we read, and when we create a model out of it. So we are going towards building a digital twin concept for your cloud. So you can now model your infrastructure as code and test it out before you actually deploy it in the cloud, but in a way where you could actually visualize how your cloud would have looked like, and how it would have behaved with respect to the violations that you are introducing because of the misconfigurations that you might have in your infrastructure as code. In fact, ours is one of the first product to do a full, threat model as well as a full visualization of your cloud right out of your infrastructure as code, and then you can simulate and model how your violations would behave. Should you productize or should you implement infrastructure as code under question into building a new cloud? So these are some of the advanced, things that are happening in this space.
I really love that because I really don't know any developer or even infrastructure engineer that can say they can build something perfectly secure and functional the first time, right? Like it's just
never happens,
right? We always push out there and go, oh, I forgot about that, right? But being able to visualize it and see that, especially with the complexity in the various cloud providers, right? Like it's super complex to manage. Basically, you're managing all of those. When you start pushing, especially into more cloud native, right? You're managing relationships between identities, services, and applications. It gets super complex, but the opportunity to be more secure is there with, I think, the proper tooling and the ability to visualize that before I deploy is awesome.
I mean, infrastructure.
I don't know about you.
Yeah, go ahead.
I was going to say, I don't know about you guys, but my code's always perfect the first time.
But you mean it compiles and go the first time, right?
Well, I wrote the compilers to that, Yeah. I need people to. I have to call out what I'm doing is really amazing. And I'm not just here to blow smoke. It's the digital twin. I don't know if that first came from GE, that concept, or might have been somewhere else on the industrial side. But you're sort of taking the idea and saying, hey, your cloud is now industrial. Or as part of your industry. I hope I'm not stretching here. I don't think I am. And actually being able to model that, right? It was some of the things that G used to do was like either having a visual model of a windmill or a jet engine and saying, hey, we're going to make the change on that device. And model how it actually changes without having something blow up in the air, which, that's pretty incredible. I don't think I've heard anyone doing that yet.
Yeah. I'm sure someday, when you guys have time, I'll be happy to show you how it all works. We are in the quite a exciting stage with respect to that, with respect to that feature. But I want to quickly add to the point that Paul was raising. The infrastructure as code has now, enabled security teams or security product vendors such as ours to do security of absolute next level. So take an example, right? There was no way, I would say, a couple of years ago to determine that. Let's say you have an application that you have packaged in a container image, right? There was no way to determine for the infrastructure folks to identify that this container image now is actually going to run on which pod, and that pod is going to live on which worker node in case of Kubernetes, and that worker node is actually running on which EC2. And not just only that, but it was very difficult to figure out that now this EC2 actually is part of which namespace in the Kubernetes landscape. It's using what IAM and when it now comes back to the cloud layer, what is the region and the subnet and the VPC where this whole thing is running, and what are the interconnections between them? We are able to now do all these interconnections. So we exactly now know the container image. So we read hem charts. We know that the container image is actually going to go onto which pod, that lives in which namespace. Now that namespace has got what kind of RBACs, the IAM equivalents in Kubernetes. And then that whole thing cluster is running on what region, what subnet, what VPN. We know most of this stuff now by reading through the cloud infrastructure, declarative code, infrastructure as code. And these are the things that we're able to put together when we identify violations and connect them together to give you a full holistic view of what would have happened in your cloud environment if you were not to take care of certain security situations. And then we also give you the remediation for that because we have the infrastructure as code.
That's outstanding. I love that. So this is something that you would implement early in the process, right? Because I mean, my processes might differ from other folks too, right? But building out this infrastructure, there's a lot more upfront work, right? Than when it's actually up and running. Like, to repeat that process is pretty easy, but the upfront work of knowing in all of the examples you gave, right? Inside my container to Kubernetes to inside my cloud, what all the roles, settings, where and how everything runs is super complex. And I think that, like, at what stage do you find people are implementing this type of visualization? Does it help basically in the design phase all the way through running in production basically?
Yeah, so there are adoption stages. Different customers are in different stages today. There are class of customers who are very mature in the infrastructure as code. Let's say 80% of their cloud environments are built using ISC. For those customers, they immediately tend to utilize our technology at a pre-commit stage or at a CI/CD stage. So we have integration points available with CI/CD. One very interesting change that I'm observing in industry is that the CI tools are adding CD capabilities, and of course because of the fact that the new CD players are emerging in the market like Harness and Spinnaker. So the Jenkins and Circle CIs of the world also have to start adding the CD capabilities. And CD is the actual capability which is allowing organizations to deploy the cloud at rapid speed and rapid scale using infrastructure as code technologies. That's the stage where a lot of times our technology comes into the play, and we act like gatekeepers there. At the same time, provide visualization. But then there are organizations which are not that much mature in their ISC journey. They are in the beginning stages, like 20% of the cloud is ISC. So those organizations like to use us in a hybrid way. So they use us in pre-commit stage, as well as we scan your running state of your cloud as well.
Oh, I'm dropped off there for a moment. Lost audio.
Yeah.
You still there?
In the running state.
Oh, he's back.
Should I blame it on Comcast?
Yes, you can blame it on Comcast for sure.
So yeah.
You were saying that if you have 20% of your cloud being deployed as infrastructure as code, you may use it for that. But then the other 80%, you can interface directly with the cloud provider and provide value there as well, right?
Correct. Yeah. So we continuously monitor and scan that, and then we provide a very important aspect of immutable security, which is posture drift. So we are able to then tell that how much are you drifting between your ISC and your cloud? What are those resources that you're building without using ISC? And how are they trending in terms of drifts as well as violations? And we're able to do all of this now without requiring any kind of agent deployment, only through read permissions. Of course, we tap into the control planes of cloud providers, Kubernetes, and Service Mesh and then read the configurations for all these three different layers.
Outstanding. John, further questions?
Where do I go to get this?
Yeah, exactly. We want it.
Yeah, absolutely. So we are live. Anybody can go to our site and do a 30-day free trial. There's a freemium version available. We also have our open source tool, TerraScan, now. which is available as part of the individual download, or it can be utilized as part of the GitHub's Superlinter project. So we are the first security assessment tool as part of the Superlinter project. So you could utilize there. We are also available in different marketplaces. Circle CI. We are located in different marketplaces, including Bitbucket. So you can definitely GitHub. So you can download from there and start playing with it from the static analysis point of view. If you want to just use the static analysis piece, and of course the full visualization and the other gamuts of features are available in a freemium version. You can download it from our site and start playing with it.
So unless you're John and you write perfect code every time, you should definitely visit securityweekly.com/Accurics, ACCURICS. Thank you so much for coming on and describing this process. It's really awesome.
Appreciate your time, guys. Wonderful talking to you.
And that will conclude this segment. Stay tuned for our final segment of the show coming up next.